In the last class, we were talking about moment of inertia of simple objects, point objects. And towards the end of the class, I showed you a method to find out the moment of inertia of an extended object. So to begin today's class, we'll talk about the moment of inertia of some simple objects as a revision. And then towards the end of the class, we'll learn how to find out the moment of inertia of all extended objects. So you'll be able to derive the moment of inertia of all the standard extended objects, rod, ring, sphere, disk, and also almost of any object that will be given to you in an exam. Okay, in your mains and your advanced exam. In the mains exam, you'll have direct formula-based problems, but in the advanced exam, you will be asked to find out moment of inertia of triangles, maybe part of a triangle, half circle, stuff like that. So you'll be able to do all of that. Okay, let's get started with the class. Let's try a problem. I'm giving you a triangle. Okay, there are three masses. There are three masses arranged in a triangle. So this red one is the frame. It doesn't have any mass, but there are three masses. There is a mass over here. There is a mass over here. This is another mass, and there is a mass over here. This is another mass. I'm going to give you two different axes. There is one axis over here. Okay, so this is an axis, and another axis is going to be over here. There are two different axes of rotation. So this is axis B, and that one is axis A. Find the moment of inertia about axis A as well as about axis B. Find IA and IB. By the way, when you're reading it in a book, when you see IA, so it means moment of inertia about axis A. Okay, so that subscript over there, that small letter below I, that means the axis. So find the moment of inertia of this system about axis A and also about axis B. Pause the video, give it a try. And once you're done trying, look at my solution. What I think is when you're trying to find out the moment of inertia, you should find out the perpendicular distance from the axis. So in all the problems in the last class, no object was placed on the axis itself. Here there is an object that is placed on the axis. So the distance from the axis, the distance of this object from the axis is equal to 0. Okay. You must have assumed some length. I did not give you a length over here. The length of all of these sides is L. So if you did not solve the problem because of L, pause it right now and again try to solve it. So this distance is L. It's an equilateral triangle. So what can you do? You can find out the height of this equilateral triangle, which is equal to root 3 by 2 times the side. So you could say that this distance is equal to root 3 by 2 L. That distance also is equal to root 3 by 2 L. So the distance from the axis to the mass is equal to root 3 by 2 L. अब moment of inertia निकालो, find IA. So how will you find out IA? So IA will be equal to the sum of moment of inertia. If you remember, if there is more than one object, then you will have to add. And you can add the moment of inertia only if the axis is the same. So first you are finding out for axis A. That is why I've written IA. So you can write moment of inertia of the first object. If you're numbering it 1, 2, 3, then you can write moment of inertia of the first object about axis A plus moment of inertia of the second object about axis A plus moment of inertia of the third object about axis A. The moment of inertia of the first object कितना है? M into 0 squared, because the distance from the axis is equal to 0. So right now we can just pause for a second and I can write this down so that you can note it. If an object is placed on the axis of rotation, is placed on the axis of rotation, its moment of inertia is 0. If a point object, okay, if a point object is placed on the axis of rotation, its moment of inertia is equal to 0. तो ये जो पहला वाला ऑब्जेक्ट है, इसका मोमेंट ऑफ इनर्शिया जो है, द मोमेंट ऑफ इनर्शिया इज गोइंग टू बिकम 0. Okay, for the second one, what is the moment of inertia? The moment of inertia will be equal to m into root 3 divided by 2 L squared plus m into root 3 divided by 2 L squared. So how much is that? M into 3L square by 4 plus m into 3L square divided by 4. How much is the total? 3 by 2 ml square. That is the moment of inertia of this triangle or this triangular object about the first axis. About axis A, the moment of inertia is equal to 3 by 2 ml square. Now try to find it out about axis B. You can pause the video again, give it another try. Okay? So what will you write about axis B? I'll erase all of this first. About the second axis, when you're trying to find out the moment of inertia, keep in mind that two objects are already falling on the axis. So the objects on the right, the two objects on the right, they're already falling on the axis. And there is one object which was falling on the axis before. Right now, it's no longer on the axis. It is at a particular distance from the axis. So if you write down the moment of inertia about axis B, so what will you write? You'll write IB is equal to moment of inertia of the first object about B plus moment of inertia of the second object about B plus moment of inertia of the third object about B. With this new axis, you will see that these objects, the distance from the axis is equal to 0 because they're on the axis. So for the second and the third object, the moment of inertia is equal to 0. But for the first object, the moment of inertia will be how much? M. What is this distance? Root 3 by 2L. That's the height of the equilateral triangle. So root 3 divided by 2 L squared. So what is the moment of inertia? The moment of inertia about axis B is equal to 3 ml square divided by 4. How are the values different? If you remember from the last class, the moment of inertia depends on the axis of rotation. It depends on the axis of rotation. If you change the axis of rotation, the moment of inertia of an object will certainly change. अगर axis of rotation को बदल देंगे, shift करेंगे, तो moment of inertia change हो जाएगा. ठीक है? Moment of inertia is not a constant. It is dependent on the mass. It is also dependent on distance from the axis. So if you change the axis, the distance from the axis is going to change, and the moment of inertia of the object will change. Okay? By the way, if you have any questions at all, you can leave it in the comments for this video. I'll come back and I'll try to answer them in a further video. That's the one way that you can talk to me. Leave your questions, comments, or whatever it is in the suggestions in the comments. Okay, let's try another problem. Let us say that there is an axis, and there is a rod that is inclined at 30 degrees to this axis. So it's a massless rod. This rod doesn't have any mass. On this rod, there are three masses. So this is one mass over here. This is A. There is one mass over here at the middle of the rod. That mass is B. And there is one mass at the end of the rod, which is C. Three masses are there. And the distance between the masses, the length of the rod is equal to L. The length of this rod is equal to L. The masses are M, again M, and the last mass is also equal to M. All three masses are the same. One is at the middle of the rod, one is at the end of the rod, and one is at the beginning of the rod. Let us say that this angle over here is equal to 30 degrees. Find the moment of inertia of the system. Find the moment of inertia of the system. That's the question. About what axis? About the axis that is given to you. So if you want to call it axis 1, then find the moment of inertia about axis 1. Find I1. So when you're watching this video, you know how to find out the moment of inertia. You have to take the mass. You have to take the perpendicular distance from the axis, mr square karo. And then because there is more than one object, you can add up the moment of inertia, but the condition is the axis should be the same. So here the axis is the same. Find out the total moment of inertia. Pause the video, give it a try. Okay? I hope you have already tried it. You paused the video and you gave it a try. If you aren't doing that, pause it, give it a try. Fine. So I hope you have tried it now. Let us say this is the mass that we are taking, the middle one. So this is the distance. This is A, this is B. So this is RB. What is RA? RA is equal to 0. We can directly say that the moment of inertia of object A is equal to 0. What is RC? This distance has to be taken from the axis. The distance has to be perpendicular to the axis. ये 90 degree होना चाहिए. So RC is equal to whatever it is. This value we'll find out from trigonometry. That's the value of RC. It should be perpendicular to the axis. Fine. The length of the rod is equal to L. This angle is 30 degrees. So I think I can say that RC is equal to L sine 30. RB will be equal to, this is half the length of the rod, so I can write L by 2 sine 30. Sine 30 is equal to half, so I can write L by 4. In this case, I can write L by 2. Now let's find out the moment of inertia. So I1 is equal to moment of inertia of object A about axis 1 plus moment of inertia of object B about axis 1 plus moment of inertia of object C about axis 1. क्या क्या आएगा? Moment of inertia of A is mass of A, distance from the axis 0 squared, plus mass of B, distance from the axis, which is equal to L by 4 squared, plus mass of C, distance from the axis L by 2 squared. How much is that? 0 plus ml square divided by 16 plus ml square divided by 4. How much is that? 5 ml square divided by 16. So moment of inertia of such a system is equal to 5 ml square divided by 16. Okay? If you understood this problem, try to find out the moment of inertia of exactly this system about the second axis, axis 2. If you understood it, find the moment of inertia of the system about axis 2. Pause the video right now. Give it a try, it should be easy for you. Find out the distance of each mass from the axis, then add up. Okay? I hope you have done it. Let us say the distance from the axis for all the three masses we have to find out. So this is the distance from the axis. I have to also call this distance as RC. So what I'll do is I'll change the colors a little bit. So let us say this distance over here is the new value of RC from the new axis. Okay, so this is RC for the new axis. This is RA for the new axis. It's not 0 anymore. It's going to be something else. And RB is obviously equal to 0. Now let's find out the moment of inertia. अब कितना होगा? तो I2 is equal to moment of inertia of object A about axis 2, moment of inertia of object B about axis 2 plus moment of inertia of object C about axis 2. What is moment of inertia of object A? It is equal to mass into distance of A. What do you think the distance of A is? This angle will also be equal to 30 degrees. This distance is L by 2. So this distance, we have already found that out before, is equal to L by 2 sine 30. Sine 30 is half. So that is L by 4. So we'll just write L divided by 4 squared plus B is already on the axis. You can write 0. Even for C, that distance is L by 4. So you can write M into L by 4 square. Notice that when we are changing the axis, the mass is obviously not changing. How does the mass depend on the axis, right? The mass is not going to change. Distance from the axis will change. That's why the moment of inertia changes. क्या लिखेंगे? ml square divided by 16 plus ml square divided by 16. So the value will be equal to ml square divided by 8. So by now, if somebody asks you why is the value different, you can easily explain why the value is different. That's what I wanted to teach you. If the axis changes, the moment of inertia of the system is going to change. Okay? I hope you're okay with all of this. Let's start with the real material for today's class. Today's class is all about finding the moment of inertia of an extended object. हमें एक extended object का moment of inertia निकालना है. What extended objects do we plan to solve? We wanted to solve for a rod. We solved for a rod in the last class. Though in today's class we'll find out the moment of inertia of a rod about the edge of the rod. Okay, that's the first thing we'll be doing today. The next thing we'll be talking about is the moment of inertia of a ring, about the center of the ring, moment of inertia of a ring. The third thing we'll be talking about is the moment of inertia of a disk, like a biscuit. The fourth thing we'll be talking about, if possible, is the moment of inertia of a shell, which is an empty sphere. The fifth one we'll be trying to talk about is a sphere. We'll be doing all the derivations, so it's going to take some time. Okay? Moment of inertia of a shell, moment of inertia of a sphere. And then, if time permits, we'll try to do some moment of inertia theorems. There are two theorems you need to know about, the perpendicular axis theorem and the parallel axis theorem. Before we get to all of that, let's start doing all these derivations. The moment of inertia of a rod about the edge. Do you remember what the process is to find out the moment of inertia of an extended object? If you have an extended object, there is a three-step process to find out the moment of inertia. First of all, you draw your object, and then you take a very small part of the object. What is a very small part of the object called as? A very small part of the object is called as a mass element. Okay, this is called as dm. Dm matlab part of m. Dm, mathematics differential of m, which in English means part of m. So this is a very small part of the object. It is so small that it actually behaves like a point. If you saw the first lecture, you must know that the moment of inertia of a point object is mr square, not of any object. Only for a point object, moment of inertia is mr square. So if you take a very small part of an object, it behaves like a point object and it is called as a mass element. ठीक है, इसको mass element कहते हैं. नेक्स्ट थिंग व्हाट डू वी वांट एन एक्सिस ऑफ रोटेशन. तो यहाँ पे एक्सिस ऑफ रोटेशन क्या है? द एक्सिस ऑफ रोटेशन इज द एज ऑफ द रॉड. So you'll be taking the edge of the rod and taking the left edge of the rod. This is my axis of rotation. That class we took the middle of the rod. Next, what will you do? You will say that the distance from the axis of rotation is equal to x. ठीक है? Each mass element that you take is going to change x by a small amount. That small amount is dx, the differential of x. Now we'll use simple mathematics. The length of the rod was L, the mass of the rod was m, so there is a mass per unit length, m by L. Because the small element is a part of the same rod, I should be able to write dm divided by dx. They are both equal, it's part of the same rod, it's a uniform rod. So I should be able to write dm is equal to m by L dx. ये अपना पहला relation है. This is step one. If you don't remember, go back to the last lecture, you will see this. This is basically step one. We try to take a mass element. क्या करते हैं? We take a mass element and then we try to find out dm. dm को dx के terms में लिखते हैं. What is x? X is the distance from the axis of rotation. What is dx? Size of our mass element. ठीक है, समझ में आया पहला स्टेप. सेकेंड स्टेप इज टू फाइंड आउट द मोमेंट ऑफ इनर्शिया. मोमेंट ऑफ इनर्शिया डायरेक्टली नहीं निकाल सकते. वी कैन फाइंड आउट द मोमेंट ऑफ इनर्शिया ओनली फॉर दिस वेरी स्मॉल पार्ट. So if this rod is rotating, this small part is going to move in a circle of radius x. So right now we can write di, not I, but di is equal to x square dm. क्यों? मोमेंट ऑफ इनर्शिया इज एम आर स्क्वायर. तो m को मैंने यहाँ पे लिखा है, एक्स स्क्वायर को यहाँ पे लिखा है, डी आई इज इक्वल टू एक्स स्क्वायर डी एम. राइट नाउ सब्सटीट्यूट. तो एक्स स्क्वायर कम्स इन एज इट इज. व्हाट इज द वैल्यू ऑफ डी एम? डी एम इज इक्वल टू एम बाई एल डी एक्स. दिस इज द वैल्यू ऑफ डी आई. अच्छा, व्हाट इज द मिनिमम वैल्यू ऑफ एक्स? 0. व्हाट इज द मैक्सिमम वैल्यू ऑफ एक्स? एल. So the limits of integration will be 0 to L. In the third step, we'll be integrating. So the third step is to integrate. Step 3 is to solve. Solve matlab we have to integrate this thing to find out our answer. So we'll basically write the net moment of inertia is equal to the integration of di. How much is that? Integration of x square into m by L dx. So whenever you're going to do an integration, there will be a start and there will be an end. So the start is 0, the end is L. Those are the limits of the integration. समझ में आया? Take a moment, reach this point. ठीक है, वीडियो को पॉज कर दो. Take a moment, reach this point. Once you're done with this, let's start solving the integration. M by L बाहर निकल जाएगा because it's a constant. Integration of x square, if you remember, if you have x to the power n, the integration of x to the power n dx is equal to x to the power n plus 1 divided by n plus 1. So we'll apply that logic over here. तो ये कितना हो जाएगा? x to the power 3 divided by 3. What are we integrating? From 0 to L. So how much is the value? M by L. Put the first one inside. So you'll get L cube. Okay. Put the next one inside, the lower one inside. That you will get 0. So the answer is M divided by 3L into L cube, which is how much? ML square divided by 3. समझ में आया? The moment of inertia of a rod about the edge is ml square by 3. Let's just summarize both the results once. For a rod, for a thin uniform For a thin uniform rod, the moment of inertia about the center of the rod is ml square divided by 12. And for the same rod, the moment of inertia about the edge of the rod is equal to ml square divided by 3. Take it, two things. There's a small disconnection in between, so you need to go back to that previous slide, though I derived it completely before things went wrong. So go back over there, pause the video, try to do it once or twice on your own. It's an integration, pretty straightforward integration. So for a straight rod, thin uniform rod, nothing special with the rod, ml square by 12 about the middle of the rod. And if you take the edge of the rod, it is equal to ml square divided by 3. Okay? This is the moment of inertia of a thin uniform rod. Now the next thing is, if you take, for example, a disc. Now if you take a disc or if you take a ring, पहले ring को कर लेते हैं. If you take a ring, So what is the moment of inertia of a ring about its center? You take a ring, okay, then the center of the ring. तो मैं निकालना है इसका moment of inertia क्या है. The first thing is you take a very small part of the ring. As usual, step one, take a very small part of the ring. Now, when you take a small part of a rod, that small part is going to have some length, dl. Here, this very small part, it is going to have a very small angle at the center of the ring. Let us call it d theta. Okay? Now, if the entire ring has a mass of m, this entire angle you will recognize is 2 pi. You might say 360 degrees, but I will say that it is 2 pi radians. Right now, you have studied enough physics to understand what's radians. So we can write m by 2 pi. You will call this small mass. What will you call it? It's a mass element. So you will write that it is dm divided by d theta. Okay? I hope you understood how to write this relation. So now you can write dm is equal to m by 2 pi d theta. That's your first step. By now you know how to write this step. Second step, you will want to write down the moment of inertia. So step 2, write down the moment of inertia. What is the axis of rotation? This is your axis of rotation. What is the distance from the axis of rotation? Radius of the ring, r. So you will write di is equal to r square dm. Is the distance different for different masses? No. It's a ring. All the points on the ring, they are at the same distance from the center. So R is the same for all of the masses. किसी में कोई फर्क नहीं है. सबके लिए R same है. So you will write R square multiplied by dm. So dm is how much? M divided by 2 pi multiplied by d theta. So this is the value of di. Third thing, step 3. What is the moment of inertia? So we will say that we'll have to use integration. So I is equal to integration of di. अब मेरे को ये बताओ, if you're looking at it from the top, what is the minimum value that theta can have? 0. As you increase it 90 degrees, it will go to 180, it will go to 270, it will come back and again it will be 0, but now you will call it 360 degrees, which is 2 pi. So the limit of this integration, when you are writing r square into m divided by 2 pi d theta, the limit of this integration is from 0 to 2 pi. So always we write the from value नीचे, 2 value is ऊपर, तो 2 pi. So m r square divided by 2 pi, all of these are constants, integration of d theta. So what's the integration of d theta? It is just theta. So you will write m r square divided by 2 pi, the integration of d theta is simply theta from 0 to 2 pi. So you will put 2 pi, you will put 0. So you will get m r square divided by 2 pi into 2 pi minus 0. तो कितना हो जाएगा? ये 2 pi and this 2 pi will cancel. So the moment of inertia of a ring is simply mr square. What is the moment of inertia of a ring? The moment of inertia of a ring about its center or about its midpoint, its center is mr square. ठीक है, लिस्ट बनाते जाओ, मेक अ टेबल ऑफ ऑल दीज थिंग्स. The moment of inertia of a rod about its midpoint is ml square by 12. The moment of inertia of a ring about its center is equal to mr square. Moment of inertia of a rod about its edge is ml square by 3. You will require all of these while solving problems. तो याद रखते जाओ. इसका derivation भी important है. If you read the derivation, you'll be able to easily get it on your own. Take a piece of paper, pause the video right now, give it a try. ठीक है? So once you're done with this, we'll start doing moment of inertia of a ring, of a disc. We did ring, now we'll do it for a disc. So what is a disc? Imagine something like a biscuit. ठीक है, ये तुम्हारा disc है. I'm drawing it like this. The axis is at the center of the disc and it is pointing towards you. So imagine that this dot is coming towards you. That's the axis. The disc can rotate like this. I will tell you right from now, the moment of inertia of a disk is equal to half mr square. I'm going to prove it, but अभी से जान के रखो, इसका जो moment of inertia है, it's equal to half mr square, where r is the radius of the disk. What is r? Radius of the disk. So in this case, the first step is to take a mass element. Except the mass element is not a very small part of the disk because we'll have to take so many different parts to find out the entire disk. So what I'll do is instead of taking a very small part, I'll take a different kind of part. I'll take a ring in the disk. So kind of think of an onion. Okay, it will help you a lot. Think of onion rings. ठीक है, तो इसका जो एक छोटा सा स्लाइस अगर तुम लोगे तो it is going to be made up of lots of rings inside it. So this is one ring. It's a mass element. The mass element is dm. So one thing over here, why didn't I take a point mass? I did not take a point mass because right now I also know the moment of inertia of a ring. The moment of inertia of a ring is equal to mr square. So if the mass of this ring is dm, I know that di, moment of inertia of this mass element, is equal to dm into r square. What is r? R is the radius of the ring. That is why I took a ring. Otherwise, I could have taken a point mass. If you take a point mass, you'll have to take lots of them. You will also have to take lots of rings, but not that complicated. So as we proceed further, we can use the moment of inertia of the objects we know to find out moment of inertia of more complicated objects. तो यहाँ पे क्या कर रहे हैं? We are taking the mass element as a ring. So your first step one is to take a ring shaped mass element. A ring shaped mass element. ठीक है, क्या कर रहे हैं? एक ring shaped mass element ले रहे हैं because we know the moment of inertia of a ring. So what is the mass of this thing? The mass of the entire ring is m. समझ में आएगा? Mass of the entire ring is m. Where is the mass spread out? It is spread out over the area of this disk. Mass of the entire disk is m, and the mass is spread out over the area of this disk. So that is equal to pi capital R square. Now, what about the mass of our very small element? So it is dm. The question is, what is the area of this small thing? The area of the small thing समझने के लिए पहले ये चीज समझो कि the thickness of this is going to be dr. Think of an onion, like I said. So the thickness of a very small ring is going to be dr. Now you cut it from one place and you stretch it. So if you stretch it, you're going to get a strip. You can do it with an onion. So I told you, think of an onion. So this is dr. The thickness is dr, and the length is how much? 2 pi r. So what is the area? 2 pi r dr. ठीक है. Now that I've suggested an onion so many times, इसको हटा देते हैं यहाँ से. Let's first complete our first step. So I explained to you, we are taking a ring because we know the moment of inertia of a ring. Now I'm completing my first step. I'm finding out the mass of that element. So I will now write dm. dm is equal to m divided by pi r square into 2 pi r dr. What is capital R? Capital R is the radius of the ring and it is a constant. What is small r? Small r is the radius of my mass element and it is a variable. Pi तो कट सकता है, तो dm is equal to 2m divided by r square into r dr. ठीक है, अपना पहला स्टेप कंप्लीट हो गया. We have this one. Now we can write our second step. Our second step, step 2 on the left side of the screen, is to write that di is equal to r square dm. अपन ये लिखते हैं. Why? Because the moment of inertia of a ring is equal to mr square. So I wrote m, I wrote r square. So moment of inertia is equal to r square dm. So r is obviously r. So r square. Now what is dm? dm is equal to 2m divided by capital R square multiplied by r dr. Multiplied by r dr. ठीक है, तो just combine everything. 2m divided by r square r cube dr. This is the moment of inertia of that small ring element. Now the third step. As usual, you will say that I found out the moment of inertia of a mass element. Now I need to integrate to find out my answer. So what is the smallest value of r? 0. What is the largest value of r? Capital R. So your small r can go from 0 to capital R. That is the range. So when you write di, ka integration is I. So you will write integration of 2m divided by r square into r cube dr from 0 to capital R. तो ये कितना हो जाएगा? 2m divided by r square. R cube integration is r to the power 4 divided by 4. You go from 0 to capital R. Put capital R, put 0. So how much will you get? You will get 2m divided by r square. If you put capital R, you will get r to the power 4. There is already a 4 in the denominator, so that 4 is going to come out over here. समझ में आया? I hope it's not cluttered. So now you cancel r square and you cancel r4 to get r square. You cancel 2, you cancel 4 to get 2. So what will you get? m, यहाँ पे r square बचा हुआ है, तो you will get r square divided by 2. So mr square by 2. What is the moment of inertia of a ring? The moment of inertia of a ring is mr square. What is the moment of inertia of a disk? The moment of inertia of a disk is mr square by 2. About what? About its center. The moment of inertia about the center of a disk is mr square by 2. ठीक है, इट्स एन इंटीग्रेशन. तो एक बार वीडियो को पॉज करो, सब कुछ एक एक बार अच्छे से देख लो. स्टेप 1, व्हाई डिड वी टेक अ रिंग? एक और बार बता रहा हूँ. Up to the point that we were solving for a ring, we knew the moment of inertia of a point mass only. वी वर स्टार्टिंग द चैप्टर, हमें पॉइंट मास का पता था. अब क्या पता है, वी नो द मोमेंट ऑफ इनर्शिया ऑफ अ रिंग ऑल्सो, सो वी कैन टेक अ रिंग शेप्ड एलिमेंट. आगे जब अपन जाएंगे तो वी विल ऑल्सो टेक अ डिस्क शेप्ड एलिमेंट. ठीक है, तो पॉइंट मास हैज डायमेंशन जीरो बाय द वे. You know that the world has three dimensions, right? The point mass का dimension zero है. So when we were talking about a ring can be made out of a wire. So a ring has one dimension. So to take the moment of inertia of a one-dimensional object, we took the mass element as a zero-dimensional object. Okay, this is a very deep understanding. If this makes sense to you. Otherwise, simple देसी तरीके से समझो. You take a disk. You already know the moment of inertia of a ring. So we take a ring-shaped element. Straightforward and simple. ठीक है, पॉज करो वीडियो को, एक बार पूरा डेरिवेशन देख लो. वंस यू डन विद दिस, द नेक्स्ट थिंग दैट वी आर गोइंग टू टॉक अबाउट इज द मोमेंट ऑफ इनर्शिया ऑफ अ स्फीयर. ठीक है, इसके बाद द नेक्स्ट मोमेंट ऑफ इनर्शिया इज द मोमेंट ऑफ इनर्शिया ऑफ अ स्फेरिकल एलिमेंट. अपन स्फीयर का मोमेंट ऑफ इनर्शिया देखेंगे. स्फीयर, लेकिन स्फीयर से भी पहले वी कैन टॉक अबाउट द मोमेंट ऑफ इनर्शिया ऑफ अ शेल. तो स्फीयर से भी पहले अपन पहले शेल को निपटा देते हैं, देन विल टॉक अबाउट द स्फीयर. द मोमेंट ऑफ इनर्शिया ऑफ अ शेल. What is a shell? You must have played with those empty plastic cricket balls, right? So all of these balls which are empty from the inside, they are shells. खाली sphere, empty sphere is a shell. तो अगर तुम एक shell लोगे, I can only draw a circle on the screen because a sphere and a shell, they are going to look the same on paper. There is no difference between a sphere and a shell. So it's going to look the same on paper. It is just empty from the inside. So the shell is going to have some very, like, low thickness. It's going to have a very small thickness on the surface. So all the mass of the shell is concentrated on the surface of the shell. ठीक है, इतना समझो कि इसका जो जितना भी मास है, it is concentrated on the surface. What is the surface area of a sphere? है ना, small things you should know. The surface area of a sphere is equal to 4 pi r square. The mass of the shell is equal to m. So m is concentrated on 4 pi r square. Now we need to think about what is the element we can take. Right now we have disk, we have ring. If you think about this, it will make some sense if you just imagine it a little bit. If I cut a very small part of the shell like this, I will get a ring shaped element. मेरे को एक ring मिलेगा यहाँ पे. I'll get a ring. ठीक है, think about this. If you cut a shell, you will get a ring shaped element. So my small element dm is actually a ring. I'm taking a ring. Question is, what is the radius of this ring? So depending on where I cut it, if I cut it over here, I'll get a very small ring. If I cut it at the tip, I will get a dot. If I cut it at the center, I'll get a very big ring. So depending on where I cut it, I will get rings of different shapes and sizes. So all of these rings have different radii, but one thing is common. This distance for all the rings is r, because that's the radius of the shell. So what I'll do is I'll say that this angle is equal to theta. So the radius of the ring is equal to small r. And now I can reason out that small r, छोटा r जो है, and capital R. The small r is equal to capital R sine theta. Look at the triangle. That angle is theta. Turn the phone around if you want. R is the perpendicular. R is the hypotenuse. So you can write R is equal to R sin theta. अपन ऐसा लिख सकते हैं. So if you write it that way, now what is the area of this ring? This ring is also going to have a small area. If you remember how we were solving for the moment of inertia of a ring, you might remember that it subtends a very small angle d theta at the center. So we can say that the width of this small ring element is equal to r d theta. तुम्हें अगर नहीं समझ में आ रहा है इस चीज को थोड़ा सा इमेजिन करो. इफ यू हैव अ बॉल इन योर हाउस, टेक इट. इफ यू हैव अ मार्कर, टेक इट एंड ट्राई टू ड्रॉ अ सर्कल ऑन द बॉल. तो द विड्थ ऑफ योर मार्कर इज इक्वल टू आर डी थीटा. समझ में आया? बॉल पे जो सर्कल बनाओगे तुम, व्हाट इज द लेंथ ऑफ दैट सर्कल? द लेंथ ऑफ दैट सर्कल इज इक्वल टू 2 पाई स्मॉल आर, which is equal to 2 pi r sine theta. Now, just like in the case of a disk, cut and open it. You will get a very long rectangular strip. If you cut it and you open it, you will get a very long rectangular strip. What's the length of this strip? 2 pi r sine theta. ठीक है? What is the width of the strip? R d theta. So we can now write, instead of our step 1, we can write the mass of our very small element is equal to dm. हमें dm ही निकालना है, that's our step 1. But we will write the area of this strip is equal to 2 pi r sine theta into r d theta. So that makes it 2 pi r square sine theta d theta. अगर ये थोड़ा सा भारी हो गया, अभी पॉज करो, गो बैक बाय 3 or 4 minutes, स्टार्ट फ्रॉम द बिगिनिंग एंड सी इट अगेन. ठीक है? I hope you saw it. And once again, if you, I'm just saying, if you cut a very small part of a shell, you will get a ring. ठीक है, imagine taking a ball and like touching a marker and like rotating the ball, तो एक circle बन जाएगा. Marker का जो width है, that is this small width over here. How much is this? That is r d theta. If you take a very small part of a circle, it is always r d theta. And now if you take this, so what is that? That is the circumference. The circumference कितना हो जाएगा? That will be equal to 2 pi r. The circumference is equal to 2 pi r. ठीक है, तो इतना ध्यान रखो, 2 pi r circumference है, इसका जो size है वो r d theta है. तो what is the area? Length into breadth, 2 pi r sin theta multiplied by r d theta, तो 2 pi r square sin theta d theta. अपना step 1 complete. अब हमें लिखना है step 2. तो what is step 2? Step 2 is trying to write down the moment of inertia of that small element. जो अपना छोटा सा एलिमेंट है उसका हमें मोमेंट ऑफ इनर्शिया लिखना है. तो मोमेंट ऑफ इनर्शिया कितना हो जाएगा? यू विल राइट डी आई is equal to r square dm. Why are we doing this? Because we have a ring. The moment of inertia of a ring is mr square, इसलिए मैंने लिखा है. अच्छा, जो अलग अलग रिंग्स हैं, there is one ring over here, there is one ring on top of it, there is one ring even above it, there is one ring below it. All of these rings, they appear to be different, but keep in mind they all have the same axis of rotation. So because they all have the same axis of rotation, for all of these rings, you can add up the moment of inertia. Just keep in mind, it's good to know this thing, that the axis of rotation is the same, so we can integrate. So r square कितना हो जाएगा? What is r? R is the radius of the ring. So what is r? R is equal to r sin theta. अपन यहाँ पे लिखा तो उस चीज को यहाँ पे लिख दो. तो you will get r sin theta. Theta is a variable, by the way. इसका square multiplied by dm. So what is our dm? We need to solve this thing. First of all, अपन यहाँ से cancel कर देते हैं. 2 pi and 4 pi. It's going to give you 2. R square is also luckily going to cancel. So the value is going to be how much? M by 2 sin theta d theta. So m divided by 2 multiplied by sin theta multiplied by d theta. कितना आ जाएगा? ठीक है, तो दिस इज योर मोमेंट ऑफ इनर्शिया. यू कैन राइट इट डाउन मोर प्रिसाइसली इफ यू वांट. तो ये हो जाएगा m r square divided by 2 sin square theta multiplied by sin theta multiplied by d theta. This is the value of di. मैंने जानबूझ के sin square और sin को अलग लिखा है. You'll understand in just a minute. Before I proceed from here, let's give you an idea of what you are going to get as the answer. The answer is going to be 2 by 3 mr square. ठीक है, तो अपना आंसर इतना आने वाला है. अब इसको सॉल्व करते हैं. What is step 3? तो step 3 is to perform an integration. So we will write I is equal to integration of di. So what is di? Di is equal to m r square divided by 2. और integration किसका होगा? Whatever is the variable is going to get integrated. तो sin square theta sin theta d theta. Actually, I should have written the integration sign instead of before, after m r square, I should have written it over here. Like, the point is, anything that is a constant will come out of the integration sign. So basically, you're integrating the variable part, this one. What is the minimum value of theta? 0. What is the maximum value of theta? How far can your maximum go? Here, right? Pi. Imagine a potter who is making like a मटका or something. ठीक है, उसका हाथ नीचे से लेके ऊपर तक जाएगा तो कितना हो जाएगा? 0 से लेके पाई तक जाएगा. So it's from 0 to pi. अब हमें करना है इसको इंटीग्रेट. इंटीग्रेट कैसे करेंगे? I know that you don't know a lot of integration, so I'll help you through this. M r square divided by 2. सबसे पहले color change करते हैं so that you can keep in mind what we are doing. Let's switch the color to something different. M r square divided by 2. ठीक है, M r square divided by 2. अब एक चीज देखो, cos theta का जो इंटीग्रेशन होता है, इंटीग्रेशन ऑफ cos theta, look at the bottom right corner of the screen. The integration of cos theta d theta is just basically sin theta. ठीक है, ये cos theta का इंटीग्रेशन है. अगर तुम cos theta का डिफरेंशिएशन देखोगे, what is the derivative of cos theta? The derivative of cos theta is minus sin theta. अपने पास यहाँ पे माइनस नहीं है, लेकिन जो साइन स्क्वायर थीटा है, साइन स्क्वायर थीटा कैन बी रिटन एज 1 माइनस कॉस स्क्वायर थीटा. 1 माइनस कॉस स्क्वायर थीटा मल्टीप्लाइड बाय साइन थीटा मल्टीप्लाइड बाय डी थीटा. तो ये हो जाएगा फ्रॉम 0 टू पाई 1 माइनस कॉस स्क्वायर थीटा साइन थीटा डी थीटा. अब इसके आगे, if you want to do the derivation again, so you can like rewind the video. So what I'll do is I'll just erase this. I don't want to turn the page. I'll erase this और अपन बाकी का derivation यहीं पे नीचे निपटाते हैं. ठीक है, take cos theta as t. This is my substitution over here. So there are two ways of doing integration. There are a couple of ways of doing integration. The way I'm using here is to take substitution. So take cos theta as t. So if cos theta is t, then minus sin theta will be dt. Derivative होता है ना sin theta minus cos theta is the minus sin theta is the derivative of cos theta. तो minus sin theta कितना हो जाएगा, dt हो जाएगा, which implies that sin theta is equal to minus dt. अब ढूंढो sin theta अपने पास है, तो sin theta d theta का जो वैल्यू होगा that will be equal to minus dt, है ना. साइन थीटा डी थीटा इज इक्वल टू माइनस डी टी, और जो वन माइनस कॉस स्क्वायर थीटा है दैट विल बी इक्वल टू वन माइनस टी स्क्वायर. तो दिस इज द रिजल्ट ऑफ आवर सब्स्टिट्यूशन. Okay, what is cos 0? Cos 0 is 1. What is cos pi? Minus 1. So all of the variables in our integration are going to change. मैंने क्या किया, cos theta को t ले लिया, तो cos 0 कितना हो जाएगा 1, cos pi कितना हो जाएगा minus 1, sin theta क्या हो जाएगा minus dt. तो now I have this integration. So I will have mr square by 2. Look at the right side of the screen. Integration from 1 to minus 1. From 1 to minus 1 of what? 1 minus t square into minus dt. इंटू माइनस. तो जब इंटू माइनस को अपन अंदर सॉल्व कर देंगे तो 1 माइनस टी स्क्वायर इंटू माइनस साइन कितना हो जाएगा, टी स्क्वायर माइनस 1 हो जाएगा. तो दिस विल बिकम टी स्क्वायर माइनस 1. सो हाउ मच इज दैट, दैट इज एम आर स्क्वायर डिवाइडेड बाई 2. टी स्क्वायर माइनस 1 कितना हो जाएगा, टी क्यूब डिवाइडेड बाई 3 माइनस टी. फ्रॉम वेयर टू वेयर, फ्रॉम 1 to minus 1. I hope you got to this point. If you didn't, take some time, get to this point. ठीक है, आगे बढ़ते हैं. एम आर स्क्वायर डिवाइडेड बाई 2. सो वी हैव सो फार एम आर स्क्वायर डिवाइडेड बाई 2 मल्टीप्लाइड बाई टी क्यूब बाई 3. टी क्यूब डिवाइडेड बाई 3 माइनस टी, एंड द इंटीग्रेशन इज फ्रॉम 1 to minus 1. अब वैल्यू सब्स्टिट्यूट करते हैं, ऊपर वाला वैल्यू पहले. तो यू विल हैव एम आर स्क्वायर बाई 2, पुट द टॉप वैल्यू, सो यू विल गेट माइनस 1 बाई 3, माइनस ऑफ माइनस 1 प्लस 1. ठीक है, माइनस, put the bottom value, so you'll get 1 divided by 3. समझ में, you'll get 1 divided by 3, and then just put 1 over here. ठीक है, you'll get this. माइनस 1 डालोगे तो माइनस 1 by 3 आएगा, माइनस 1 डालोगे तो प्लस 1 आ जाएगा, माइनस टॉप माइनस बॉटम. 1 डालोगे तो 1 by 3 आएगा, 1 डालोगे तो 1 आएगा. So you'll get mr square divided by 2. What is 1 minus 1 by 3? 2 by 3. What is 1 by 3 minus 1? Minus 2 by 3. तो minus of minus 2 by 3 और कितना हो जाएगा, again 2 by 3 हो जाएगा. So what are you getting? You are getting mr square by 2 into 4 by 3. How much is that? 2 by 3 mr square. What did I tell you? The moment of inertia of a shell is 2 by 3 mr square. ठीक है, I agree that the integration is not that straightforward. At this point you may or you may not know this much of integration. तो उसमें कोई बात नहीं है, तुम 2-3 बार करोगे तो मैंने काफ़ी इजीली समझाया है. एक बार वीडियो को रिवाइंड करो, एक बार और देख लो, जस्ट वॉच इट अ कपल ऑफ टाइम्स, यू विल गेट दिस इंटीग्रेशन वेरी इजीली. 2-3 बार पेपर पे करो, यू विल गेट इट. ठीक है, सब्स्टिट्यूशन कहते हैं, दिस इज कॉल्ड एज द मेथड ऑफ सब्स्टिट्यूशन. इफ यू डिड नॉट गेट दिस इंटीग्रेशन, प्लीज लीव अ कमेंट दैट यू डिड नॉट गेट इट. So if a lot of people don't get the integration, I'll take up integration in the next class and I'll teach it to you. Okay, बाकी इसको try करो. We could go up to shell. We cannot do another one right now because there is not enough time. So in the next class, we'll take up the sphere and we'll take up plate and we'll finish the integration of those things as well. आज के लिए इतना ही. Just to rewind what we did, we started with 2 or 3 basic problems. Point mass पे we solved and found out what is the moment of inertia of a system of particles. ठीक है, 2-3 और problem. And then I started saying that, like, if you have an extended object, you divide it into small mass elements, like we did in the case of a rod in the last class. We took up the example of a rod, but we took a different axis. We took the edge of the rod. तो उसके about कितना आता है, ml square by 3. रॉड के सेंटर के अबाउट कितना आता है, ml square by 12. सेंटर के अबाउट ml स्क्वायर बाई 12, एज के अबाउट ml स्क्वायर बाई 3. ठीक है, टेबल बना के रखो इन चीज़ों का. नेक्स्ट थिंग, रिंग. रिंग का कितना होता है, mr स्क्वायर. पॉइंट मास का कितना होता है, mr स्क्वायर. सो रिंग इज ऑल्सो पॉइंट, आई मीन mr स्क्वायर. ठीक है, रॉड, रिंग, उसके बाद आएगा डिस्क. तो व्हाट इज द मोमेंट ऑफ इनर्शिया ऑफ अ डिस्क अबाउट द सेंटर, mr स्क्वायर बाई 2. Somebody asks you in a problem, wherever it's required, you should be quick with all these things. Okay, डिस्क का कितना आएगा, mr स्क्वायर बाई 2. उसके बाद क्या करना है, शेल. तो शेल का कितना है, 2/3 mr स्क्वायर. उसके बाद आएगा स्फीयर, उसके बाद आएगा प्लेट. सो बिफोर आई लीव, आई कैन जस्ट लीव यू विद द वैल्यूज ऑफ दोज थिंग्स. यू कैन नो देम, देयर इज नथिंग रॉन्ग इन नोइंग इट. तो स्फीयर का जो वैल्यू आता है, स्फीयर का आएगा 2/5 mr स्क्वायर. फॉर अ स्फीयर द मोमेंट ऑफ इनर्शिया इज इक्वल टू 2/5 mr स्क्वायर. We'll talk about for a rectangular plate as well. So for a rectangular plate जिसका dimension A और B है, the moment of inertia is 1 by 12 m a square plus b square. For a rectangular plate, the moment of inertia is 1 by 12 m a square plus b square. So till the next class, try to do all the derivations. Be sure of it. See you there.